Good day, everybody. So let's proceed to the problems 3, 4, 5, and 6 for ideal gas law. So before that, let's have a recap. What is ideal gas law? So it is a law proposed by Emile Clapeyron in 1834. It describes how equal volumes of two gases with the same temperature and pressure contain an equal number of molecules. So the equation for ideal gas law is PV is equals to nRT, which P means pressure, V stands for volume, N for amount of substance, R for ideal gas constant, and T for temperature. So, problem number 3. Calculate the volume in ml of a 0.012 mole of gas sample at 2 atm and 30 degrees Celsius. So using the ideal gas law equation, we will find the volume. So in order to find the volume, let us find the formula for this. So divide both sides by pressure. The equation for now is V is equals to nRT over P. So let's write the given where N is equals to 0.012 mole. Temperature for 30 degrees Celsius. Remember that the unit of temperature is Kelvin. So we will convert this 30 degrees Celsius into Kelvin. So 30 plus 273 is equals to 303 Kelvin. So the pressure is 2 atm. And the R is equals to 0.0821 atm minus L over mole minus K. So always remember that the value of R is always 0.0821 atm minus L over mole minus K. So let us substitute. So V is equals to 0.012 mole times 0.0821 atm minus L over mole minus K, which is the value of R, and then the 303 Kelvin, which is the temperature, divided by 2 atm, the pressure. So let us cancel the same unit. The only unit left is liters. So V is equals, the answer is V is equals to 0.2985156 liters over 2. V is equals to 0.149 liters or 149 ml. Since that problem needs the volume to be in ml. So let us convert the 0.149 liters to 149 ml. Number 4. At what temperature will 0.654 moles of neon gas occupy 12.30 liters at 1.95 atmospheres? So using ideal gas equation, the PV is equals to nRT. Let us solve for T. In order to find the T, let us divide both sides by nR. So the equation now is T is equals to PV over nR. Let us write the given where N is equals to 0.654 mole, volume is equals to 12.30 liters, the pressure is equals to 1.95 atm, the R is equals to 0.0821 atm minus L over mole minus K. So let us substitute. Temperature is equals to 1.95 atm times 12.30 liters over 0.0821 atm minus L over mole minus K times 0.654 moles. Let us cancel the same unit. So the only unit left is Kelvin. T is equals to 23.985 over 0.053694 Kelvin. So the answer for this is temperature is equals to 446.7 Kelvin or 447 Kelvin. So let us proceed to problem number 5. If I have an unknown quantity of gas held at a temperature of 1195 Kelvin in a container with a volume of 25 liters and a pressure of 560 atm, how many moles of gas do I have? So using the ideal gas equation, PV is equals to nRT, so we will find the N. So in order to find the N, let us divide both sides by RT. So the equation now is N is equals to PV over RT, where the temperature is equals to 1195 Kelvin, the volume is 25 liters, the pressure is 560 atm and the R is equals to 0.0821 atm minus L over mole minus K. So let us substitute. So N is equals to 560 atm times 25 liters over 0.0821 atm minus L over mole minus K times 1195 Kelvin. So let us cancel the same unit. N is equals to, okay, so the only unit left is the mole. So N is equals to 14,000 over 98.1095 mole. The answer is N is equals to 142.6977 or 142.7 mole. Next, number 6. So 5.600 grams of solid carbon dioxide is put in an empty sealed 4 liters container at a temperature of 300 Kelvin. When all the solid carbon dioxide becomes gas, what will be the pressure in the container? So using the ideal gas equation, PV is equals to nRT. So the value of mole given is 5.600 grams, but the value of N should be in mole. So let us convert this 5.600 grams to mole. So convert the 5.600 grams into a mole. The molar mass of carbon dioxide is 44.009 grams per mole. So in order to get the mole, let us divide the 5.600 grams to 44.009 grams per mole. So cancel the same unit, and the answer is N is equals to 0.1272467 mole. So finally, we found the value of N. So let us proceed finding the pressure. So the pressure, P is equals to nRT over V, where the temperature is 300 Kelvin, the volume is 4 liters, the N is 0.1272467 mole, and the R is 0.0821 atm minus L over mole minus K. So substitute, P is equals to 0.1272467 mole times the R, 0.0821 atm minus L over mole minus K times 300 K, which is the temperature, over 4 liters, the volume. So cancel the same unit. So the only unit left is atm. So P is equals to 3.134086221 atm over 4. So we have the pressure of 0.7835 atm. So that's atm, I'm sorry. So I hope you understand and know already how to solve problems related to ideal gas law. Thank you so much.